Hi, this is problem 16 from the AMC 12A. It looks like our one log problem for this AMC 12A year. Let's see what we have. The graphs of y equals log to the base 3 of x, and these three other log functions are all plotted on the same set of axes. How many points in the plane with positive x coordinates lie on two or more of the graphs? So it looks like we're going to have to try to understand these four log functions, plot them on the same graph, and try to see how many points of intersection exist on that graph. So looking at these log functions, the first thing I notice is that they all have different bases. And that's going to make these very difficult to plot out. And so it looks like one of the tasks, which is actually common to a lot of AMC log problems, is to try to adjust the bases of the logs to the same number. Now, you could actually change the base of all these logs to the base of 10 if that's what you're most comfortable with, but that's not really necessary. It looks like we can probably change the bases of all these log functions to the base of 3, and that'll make it easy to plot all this out in a way that makes sense on a simple graph. So let's go ahead and do that. So our first equation is y is log 3 of x. So that's already to the base of 3, so we're all set there. Second equation is y log x of 3. And we can use the change of base rule to flip the base with the argument of the log. And we know then that this is 1 over log to the base 3 of x. That's pretty simple. I think we know how to graph that. Third one is y of log 1/3 of x. And here again we can use the change of base rule to find that this is equal to log to the base 3 of x over log to the base 3 of 1/3. And this bottom number is minus 1, so this is just minus log of x. And the last equation, you have y of log to the base x of 1/3. And here again we can just flip the bases, x with 1/3, which just gets the reciprocal of equation number 3. So we quickly find that this is equal to minus 1 divided by log to the base 3 of x. So it looks like we have all the information now to graph these pretty quickly, so let's go ahead and do that. So again, we're only dealing with the positive x-axis. Y is positive and negative. So let's see here. Let's make a few tick marks to indicate points of interest. 1 and 3. So log to the base 3 of x, all log functions go through 1. And for a base of 3, we find that when x is equal to 3, the log of 3 is equal to 1. So we can quickly write out that the first equation looks something like that. That's the first graph. Here we're trying to find the reciprocal of the first graph. And what that does is that when the graph goes through 0, the reciprocal basically shoots off to infinity. So that graph looks something like that. And the third graph looks like to be just the negative of the first graph. So we can just basically take this graph and flip it over the x-axis. So that gives us something that looks like that. And the last one looks to be just the negative of the second graph. So we can take the second graph and just flip it over to generate this graph. And we quickly see that the points of intersection that are called for that lie on two or more of the graphs is this point, this point, this point, this point, and this point. And that's 5 such points for choice D. Anyway, a fairly simple problem if you understand how to change the bases of logs. And it's kind of one problem that usually shows up on most every AMC. So it's good to brush up on these rules if you're not familiar with them. And we'll see you at the next video. Take care.